Now that I'm done solving the world's problems. Alright, so what's an organic compound? What do you think?
A compound with carbon.
Carbon and hydrogen.
Oh, you want to say? I'm sorry. I'm going to do that. I got one.
A compound with a carbon and hydrogen background. And sometimes oxygen, nitrogen, sulfur, and halogen.
Oh, halogen.
All right.
Is water an organic compound?
As long as you put
Water.
Yeah, alcohol.
Water. Water. Miss Patty,
Mm-hmm.
is water an organic compound?
Does it contain carbon?
Oh,
All right. So, what are the major classifications of it?
Dead or alive?
Liquid, gas, and salt.
Nope, those are the major classifications of matter. You have alkenes,
Guinness. Yo, Guinness.
alkanes,
Acidize? Oh, that sounds like a word too.
and alcohol.
Alcohol.
All right. So, you've got four major classifications.
It always ends in E. It means
Okay.
except for alcohols.
Well, the NES doesn't matter. It's the letter in front of that matters.
Y-A-E.
Okay.
Yale? Yale?
A-L.
Ale?
Is that an A?
Are they all alkaline?
Okay. No.
No. Darn.
All right.
1 second.
So, the ending is going to be important because it's going to help us recognize what type of bond type they have, how they're connected.
Yeah.
Alkenes, alkynes, alkanes, alcohols. ALKYNES. And then alcohols. ALCOHOLS.
Elephant? Oh, I use those.
All right. We good here? Yeah?
Alkalius, alkalianes, alkalianes.
No, it's not Spanish. Don't even try. All right. Here we go. We're going to start with alkanes. Alkanes are carbons that are single bonded together. Each carbon gets 4 connections. Hydrogens will fill in the other spots. The general formula is C to the N, H to the 2N plus 2. So if N is 3, H is 8. Okay? We're going to go through the general example of all 4 types, and then we'll go through the rules, and then we'll do some practice looking at each of the types. And we may not get through all of that today. We may have to save some of it for Monday just because of time. What you got, Elijah?
What is 2, like the 2n plus 2, what is,
That means the difference in the hydrogens compared to the carbons. So if I have 4 carbons, I'd have 10 hydrogens. So I take the number of carbons, double it, and add 2, and that's how many hydrogens I get.
oh. It's like algebra?
Yeah.
I like algebra.
Okay. Let me know when I can flip. What you got, Dee? Where'd I get 8? It's an 8. That's an H. A really bad H. That's an 8.
See, we should have figured it was just the same formula.
All right. All right.
It's the same formula.
All right. Then we have alkenes. Alkenes still have a carbon backbone. They have at least one double bond somewhere in the backbone. A double bond will be represented by what looks like an equal sign between 2 of the carbons. The rest of the spots will be filled with hydrogens. Their general formula is C to the N, H to the 2N. So, for example, if N is 6, H is 12. Right.
Do we ever use the... Wait, hold up. The electrolysis machine?
Possibly. All right. Alkynes. Alkynes are a carbon chain with a triple bond somewhere in there. Hydrogens fill the other spots. And the general formula is C to the N, H to the 2N minus 2. What you got, Josh?
this a general formula? That means some doesn't follow that formula?
Correct. And we'll get there. Some won't follow the general formula, and that's when you have what's called a substitution. And alcohol was a form of a substitution, where you take off an H and put on an OH.
That's nice.
So, if N7H would be 12 in the form of an alkyne.
I have another question.
Uh-huh.
Is this alcohol the same as the alcohol that we think? Like the
Uh-huh.
oh, it is? Okay.
For real?
Uh-huh.
I'm not excited. It's just surprising. I'm curious. Yeah. And I wonder if you add an orange thing, can you are you? What? Yeah, I mean, obviously it's right there in the science, maybe that one step, but then another.
Yes.
See? And that could be deadly.
Very much so.
Make alcohol? Let's not grow it.
So you have to.
It,
you have
well,
to make sure you.
there are different forms of alcohol. There's, because like the kind that you drink is ethanol.
Does that come from potatoes?
Corn. Well, it can. It can come from potatoes. It can come from corn. It can come from barley. It can come from wheat. But then it can also be used to make gasoline. But then propanol is a form of alcohol, and one format of it is used for rubbing alcohol, which can sterilize stuff before they give you a shot.
That's cool.
You know? So, alright.
Which alcohol are you gonna like? Because you know how to make regular alcohol. What chemical has to be missing for it to become like something really, really deadly?
No, it's not. No, it's not that it's deadly. It's that it's concentrated. It's what's called proof. It depends on how concentrated it is, and typically what's added to it compared to what's removed from it. All right, here we go. Move it. Hey guys.
Boy.
All right. Alcohol. They use an alkene, alkyne, or alkane backbone, but you take off at one or more OHs or H's and put on an OH, which will act like an alcohol group, and it gives it a different functionality. We good here? However, back on these last few slides, I've shown you molecular formulas like C3H8,
Yes.
C6H12,
Yes.
and C7H12.
Yes.
That doesn't tell you a whole lot. It doesn't tell you the name of the compound. It doesn't tell you. Whereas with ionic and covalent compounds, you can tell the name just from looking at the formula. With organics, you can't. You have to see what's called sometimes the structural formula, or you have to see the name. The structural formula is a drawing. It shows all the elements and all the bonds. Because the bonds are going to be important to know how to name it. Because in an organic compound, you can have the same molecular formula, but different structural formulas. Those are called isomers. Because you can have isomers, that means they can have different shapes. Those different shapes mean that you're going to have things look different, right? You can have a set of Legos, right? And you can make it the way it says on the package,
Like a tree.
but you can also make a bunch of other things, right?
A gun.
That's an isomer.
I got a question. Is isomer related to polymer?
No, not exactly.
Oh.
Isomer means that it's just something with a bunch of different arrangements. A polymer means it's one thing that's small that is then repeated and put together
Like a chain?
in a chain.
Okay.
How an organic,
What you got?
is it organic compound?
Uh-huh.
Okay. You caught that.
Drawing of how an organic compound looks, showing all the elements in the box.
What did you say it was? How did you explain isomer?
An isomer it's like having a box of Legos, and you can choose to make it like the picture, or you can choose to use the Legos to make whatever you want, right? You're still using all the parts. You're just doing something different. That's an isomer.
Whoa.
All right?
T541.
So over the next couple slides, the rules are kind of lengthy for how to do it, but then we're going to go through the process and practice the rules together
Yes.
and do a few examples.
Yes.
And then it will make pretty good sense. When I give you your packets here in a bit, you're going to get one copy from me. If you lose your copy,
God.
you're going to have to find your own. It's posted to the choice board on Schoology, and you'll have to print it yourself or whatever. I'm not giving you a second copy. What you got, G?
Is this the same as the other packet we had where we turn it in Monday and it's like the final grade?
Nope.
Oh, okay.
Nope.
Oh, okay.
All right, here we go. What you got?
Oh, is it
I was
8?
going to ask how long it is next.
5 pages.
So 10 pages?
Yeah, but part of it's notes. Like,
Okay.
it's a lot of notes with a bunch of examples for you to try, and then it gives you the answers to part of it and part of it too.
So like the last packet?
Kind of, sort of. All right.
Asking the real question.
So here's the rules. The first thing that you have to do is you have to find the longest carbon chain. So there might be a part that goes vertical and the part that goes horizontal. If the part that goes vertical only has 3, but the part that goes horizontal has 7, you're going to name it going off the part that goes horizontal. Then you're going to look at the connections between the carbons to get the suffix. Is it going to be an ane, an een, an ein? Or does it have an OH hanging off of it to get an all? You have to give the bond, if it's got a double or a triple, an address. What carbon is it on? If it has an OH, you have to give that an address. And if it forms a shape, you have to give that a prefix. And that prefix is cyclo. C-Y-C-L-O. Yes, sir. So far so good. The girls are working.
According to plan. He knows it happened, you know,
Is there an accordion?
I'm sorry.
For now. That's what I'm talking She had a license to use this. No, you have a license to shoot.
What does she mean? That's worse.
Well, I think she means like I see. Eight.
That's different. But those are for iron. Yeah.
That's what I thought too, but that's what she was saying.
Just ask her when she was back Oh, Miss Betty, what prefixes are you talking about for number one?
We'll get to it. It's the pink slide that's coming up. Alright. Okay, if you see a halogen, it takes off a hydrogen, and it also gets a numerical location. And it's named by its root. So F is fluoro, Cl is chloro, Br is bromo, I is iodo. If you get a side chain of carbons that are short compared to the long chain, they get a numerical location and a YL on the end of their name. So like a 2-carbon side chain would be called ethyl.
Do we have to memorize this?
Sort of, but you'll get used to it with practice.
Okay, I got a question. Is this one of the things where you have to write down a lot of the stuff down, but when you start doing it, it's not really a lot?
Right. It's one of those things, the rules are a lot wordier than it actually is in practice. And there's just no way to simplify it. I've tried over the last 10 years. All right.
Did that say root?
Roots.
It's roots.
You will notice that the last 6 prefixes are the same as what's in covalent. What's it, Jimmy? You can write these onto your periodic table or your equation sheet, but make sure you label them so that you know they're different from the covalent ones. All right? Here we go. Here's where you need to quit talking and pay attention. Alright. So we're going to do a few of these and we're going to dissect the name. No, that's not. Or
Is
the
this chemistry?
I like that
You don't work with animals. Three or four. 3 or 4, my friend. My friend, we shall make it. This life is the destination.
All right. So when you dissect a name, you have to break it into its prefix and its suffix. All right. So we have butane.
Where do we write this at?
These are just examples. So in your notes.
Oh, in the notes.
All right.
Thank you. Thank you so much.
I don't see it.
All right. So but is the number of carbons. What does but stand for? 4. So I'm going to put 4 C's. 1, 2, 3, 4. Ane is the type of bond between the carbons. All right? So, ane, what does ane mean?
Alkane with
Ane means alkane, which means single bond. So I'm going to connect the C's with single lines, or kind of a really bad straight line. But you would, it's really going to.
Oh, like ethanol. So ethanol would be 2 alcohols.
All right. So it's just going to look like this. 4 C's with 4 lines. Okay? Now, carbon gets 4 lines to it. All the other spots get hydrogens. Okay? So this one has 1, 2, 3, 4. Right? This one has 2, right?
yes.
So I'm going to put 1 down here, 1 up there.
If you were listening, you would have heard.
Damn.
1 here, 1 here. All right. All right. Hey guys, I was serious on the don't talk part. Okay, so remember how the general formula is C to the N, H to the 2 N plus 2. So I have 4 carbons, right? So my molecular formula would be C4. 8, what's 2 times 4? 8 plus 2. 10.
Yes.
So I ought to have 10 hydrogens.
Yes.
If I know my general formula, I can double check myself to see if I did my structural formula right by counting what I drew. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yes.
So I did.
Yes.
Okay?
You're right.
Is there easy way to
That is a
Huh?
Yeah, but I don't want to control.
But you have to be able to
It's literally
know what it looks like. All right. Let's do another one.
Yes.
We good here?
Yes.
Yeah.
Hell no. It's an alcohol. There's 6 and it would be an alkane. Alkane. Hey, alkane.
That's all right.
Miss.
Yeah.
How'd you get that and off?
Jay, I'll get there. All right, LOC, location. All right. So,
Would that mean it would be the third letter?
when you have an alcohol, the naming for alcohol takes off the E of hexane, hexene, or hexine, and puts on OL.
Alkanes.
So it's an alcohol, but it's a single bonded alcohol. The AN tells you it's single bonded. Okay? How many carbons do I have? 6. It's 6. It's hex. So it's 1, 2, 3, 4. What is that? Look at that.
Oh.
5, 6. Okay? They're single bonded because of the AN. Okay. The 1 tells me where to put the OH for the alcohol.
Yes.
I can put it here, here, or here. Any of those 3 spots. What you got, Tim?
So does LOC mean location?
LOC means location.
Okay.
So I'm going to put it over here. All right? And the O always goes closest to the C when you write an alcohol.
Huh?
Uh-huh. It's an OH, but the O always gets written closest to the C. All right? Then, on the 3rd carbon, I need to put an F.
See that?
All right? So this is carbon 2. This is carbon 3. So I'm going to put an F up here. I could put it down there if I wanted to. I just got to put one F. All right? Everywhere else, what do I put?
H.
H.
Oh, this is H for the rest.
You know that. Yeah, Daddy. That's what I have to. Where did all those come from? I'm gonna start
Miss Patty?
Uh-huh.
The lock is telling you which seat.
Uh-huh.
So what if you have a couple of forwards, like where would it
Okay.
So that's a 1?
Yes, it's one.
I don't know, when she asked the question, I didn't have anything that maybe it was an F.
I had a question. How did you know to take the OH from the 1?
Because that's what the 1 tells me. The 1 is the address for the OH.
Oh.
And the 3 is the address for the 4.
So you can have 2. Oh, okay.
All right. We okay here?
I got
We
it.
just walked in and out.
So how does the AN tell you that what type of
Because normally it would say hexane, right? So the AN is the type of bond. Because when you put an alcohol on, you're dropping the E from hexane to put on the suffix -al.
So it'll be. So does the AN part change?
No, the AN part doesn't change.
Okay,
It's
so-
still single bonded in the middle.
Oh, so that's like alkane. So would it be hexane?
It'd be hexane. If
No,
it
for
didn't-
something else.
It could be.
So it could be.
Right. Hey guys, quit talking. Diamond, what's your question?
Okay, when you write the thing, would OH be first or last? Okay, where we're at.
Before the OH. So this would be C6H 12 FO. If I were to write its molecular form.
Okay, so how would you know it was last?
Huh?
How would you know it would be last? Because it's first.
Because the OH is just always last in an alcohol.
And so F is just always before.
So, okay, so when you're putting like the OH, it has to be on the first one.
No, in this one, it has to be on the first one.
So it has to be on the first one and then what? Does it have to be like right in front or it can be?
It can be there, or there.
Okay.
Doesn't matter. All right. Now, I'm going to give you a drawing, and we'll go with the name. Okay?
Oh.
So,
Well, it's an aim, right?
It's an aim.
Not yet.
give us
Ooh.
some time.
Ooh.
It's alkene. 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 With an F. Fluoro.
We got two more, so does that mean something?
It's an alkene.
Wait.
It has an F, so it has a fluoro. It has two fluoros. Has an
Hexagon.
Oh, I get it.
I always do. Every time she's on this, I'm like,
It's a hexagon.
you good?
Notice that double.
All right. Here we go.
Why is there not an H on top of the C's that are double
Hang
bonded?
on.
Gotcha.
No, that's right. No, wait. Hang on. Need one more.
Oh, that's
All right.
Wait, so why are you missing two?
Okay. Each carbon can only have 4 lines. So 1, 2, 3, 4. Right? 1, 2, 3, 4.
Oh.
So I can only have 4 lines, right? Now, I got to give my carbon the lowest number possible. So do I want to count from my left or my right? Does it matter this time?
Yes.
Not really, because
Not really.
it's got, I can either go 1, 2, right? Or 1, 2. So it doesn't matter, but I want to give these the lowest number possible too.
What do you mean the lowest number possible?
I gotta give this the lowest number I can when I count.
Okay.
So it's gonna be the number 2, right? And then if I can, I want to give these the lowest number possible, which if I give this the number 2, my choice is either 3 and 4 or 1 and 2. 1 and 2 is less than 3 and 4. Okay? So I'm going to count from my left. So, this is on carbon 2. What's a 4 carbon chain called?
Oh, wait.
Ooh.
Proton.
But
Butane.
Butane.
Okay, it's a double bond. So what suffix do I use?
But
Ene.
ene.
Okay, so this is a form of 2-butene. Now I've got 2 fluorines, right?
Yes.
Where are they?
At the beginning.
On 1 and 2. So I'm going to say 1, 2, difluoro. 1, 2, difluorobutene.
Will it always be fluoro or will
It could be chloro, it could be iodo. I just picked fluorine. All right. If I went from reverse, it would be 1, 2, right? And then my numbers could be 3 and 4. If I counted from my right. Let's do one more.
because you say.
No, that's not came on yesterday, but there's the whole
You lost it.
I did not. That's an H one.
Is that an A?
No, it's an H.
It's an H.
That counts. 4, 6.
Okay, I'm lost. My head hurts.
She finished it.
It don't matter. She just netted T out of C's.
I give up. Why?
1, 2, 3.
You gotta start from the thumb.
1.
Yes. That is very possible.
Uh-huh.
When you're doing a chain, and then you see the double bond, which way does it go again? Like, do you start
You start from whichever way gives you the lowest number.
the lowest number?
Uh-huh.
So, like, if it says, like, if it's, like, 3 dash hexane, it would be, like, you start from the lowest side.
Uh-huh. All right. Where's the longest chain?
Up,
Down.
down.
No, it's long.
No. It's that one. It's that one. It's that one.
4.
It's that one. It's with the 2 double ones.
1, 2, 3, 4, 5, 6 going across. Right? 1, 2, 3, 4 going down.
Yeah, cross. Cross.
Neither.
What?
Okay.
We thought we were right.
No, they're H's. Watch.
We were so confident.
Sometimes an organic can turn corners. So we have 6 if I go across. I have 4 if I go down.
Can it go diagonal?
It can bend. So if I bend from the left, I have 1, 2, 3, 4, 5, 6, 7.
It's the corner.
If I bend from the right, I have 1, 2, 3, 4, 5, 6.
It's the corner.
So I gotta count from my left because I have to count this double bond. Okay?
Can it go diagonal?
It could if it did. Yes. What you got?
So, how do you know when it's not? Okay, how do you know when it's bending and when it's just going straight down?
You just have to look. You have to find the longest chain.
Okay.
So in this case, the longest chain starts here, goes 1, 2, 3, 4, 5, 6, 7. Okay? Alright. So, here's what you do. This piece over here is called a side chain.
Does that really matter?
Yeah, because it's got to get named. So, our double bond is on carbon 3. It's a 7 carbon chain. So it's 3 heptene, but I have a 2 carbon side chain. What's the prefix for 2?
Die.
F. So it's ethyl. What carbon is it on?
4.
It's on 4. So the name of this is 4-ethyl 3-heptene.
What apple?
Okay.
This apple.
Wait.
New apple.
No, not bute. 4 is the location.
Oh,
Carbon number 4
Triple bond. Where's the
is
triple bond?
ethyl It's not a triple bond. It's ene,
No,
not on.
ethene. Ethene, yeah,
Ethyl is these two carbons.
So why'd you put the ending with YL?
Because YL, not YNE. YL is the ending of the side chain.
Oh, okay. Because that's a side.
This is a side chain.
It's right here, number 6.
Okay, and rule 6.
Wait, where?
These two carbons right here is a side chain. Then we have 7 carbons, 1, 2, 3, 4, 5, 6, 7, with a double bond. And that double bond starts on carbon 3. Alright, we're going to practice more with this. But this is what organic looks like. Please read through the email that I sent out today, if you haven't read it already. Don't forget your ionic covalent acidic quiz is due by midnight Monday night.
It says something.